Okay, this is page 36 in your notes. So on the back side of page 35, make sure you label this one 36 in the corner. Okay, we're going to give this one the title of multiplying fractions. Now what's going to be different about today's notes compared to yesterday's is today we're going to be multiplying two fractions by each other, not just a fraction and a whole number. We need to draw a picture, so I'm going to have you draw a couple of pictures with me. Okay, the first one we're going to do, it will be 3/5 times or of 1/2. Okay, if we're timesing 3/5 times 1/2, this means we want 3/5 of 1/2. So first of all, we need to draw a picture that shows us 1/2. So go ahead and let's make a nice rectangle here. And we need half of that rectangle. So I'm just going to use this line to help me because it makes it easy. Split that into half, and we need to shade 1/2 of what we have. Okay, so this right here represented 1/2 of this whole unit. Okay, now of that, we want 3/5 of that. So this is where multiplying a fraction by a fraction, you get a number smaller than what you have. It's kind of like the decimal idea. But we want 3/5 of this half. So I'm going to split this half into 5 equal pieces. 2, 3, 4, 5. I know they're not quite equal, but imagine with me here. But I need to split the entire whole unit into 5 equal pieces. So I'm just going to extend those lines. Okay, now each one of these represents 1/5. So if I want 3 of those fifths, I'm going to take 1, 2, 3 of those fifths of the half. But what does that do for me? That gives me 3 pieces out of 10 units that make up the whole thing now. So this is 3/10. So 3/5 of 1/2 is 3/10. Okay, let's try another example. Let's do 2/3 of 3/4. So 2/3 of, and remember of means times in math, 3/4. Okay, let's draw another picture. Let's see. So I want my original picture to be 3/4. So I'm going to break this into 4 equal pieces. And of that, I start with 3 of them. So let's shade 1, 2, 3 of those 4 pieces. Okay, each one of these representing 1/4. So if each one of those is 1/4, I have my 3/4. But of that, I only want 2/3 of that. So I'm going to break this into 3 pieces, but I need to do it to the whole unit. So each one of these represents 1/3. So here's a third, here's a third, and here's a third. But I only want 2 of those thirds. So I'm going to shade 1 and 2. So the part that I shaded both colors is my final answer. So if each one of these represents 1/3, I have 2/3 of 3/4 of 1 whole unit. So my final answer is 6, and it takes 12 to make the entire unit. Now, we know about fractions. We know that we can reduce this. So what goes into both 6 and 12? 6. So I can reduce this to 1/2. So my final answer is 1/2. Let me shade that just a little bit better so you can see that. Okay. So 6/12 or 1/2 is my answer. Okay, that's how you can do it with a picture to see it. But now we're going to just practice with what we call cross multiplication. So instead of having to do a picture every time, cross canceling, let's write multiplication with cross canceling here. All right, cross canceling is a trick we can use to help us simplify before we multiply across. We're actually going to use this example to show how cross multiplication works. So I want you to write the example 2/3 times 3/4, which we just did, and we know our final answer is 1/2. But here we're going to cross cancel, which means we're going to look across from each other. So I'm going to look at 2 and 4 for now. Is there something that can, if I were to look at these two, is there a factor that goes into both 2 and 4? There is. If I divide this by 2, it can reduce to 1. And if I divide this by 4, it can reduce to 2. Okay, then we look the other direction. This is why they call it cross canceling. We're canceling out factors that are common. 3 and 3, well, 3 goes into both of them. This will give me 1. This will cancel and give me 1. Now I look at my simplified numbers and I just multiply across the top and across the bottom. 1 times 1 is 1. 1 times 2 is 2. And the beauty of this is now my final answer is as simple as it can get. If I've cross-canceled everything I can here, this will be nice and simple. Now I know some of you are going in your head, well, I could just do 3 times 2 and get 6, 3 times 4 and get 12, and then I know that 6/12 is 1/2. And yes, you can do that. But this comes in very handy when we're dealing with really large numbers. And so an example of this would be, what if we had two fractions like this? How about 5/7? We're going to times that by 14 over 55. Okay, do you really want to do 5 times 14 and get 70 and then whatever 7 times 55 and get on the bottom and then try and reduce it? It's easier if you can get the factors out beforehand. So let's look across from each other. So 5 and 55. Is there something that can go into both of those numbers? Okay, 5 goes into 5 1 time. 5 goes into 55 11 times. Okay, right there you just made 55 into 11. That's a lot nicer number to be working with. Okay, if we cross cancel this way, is there something that goes into both 7 and 14? Okay, 7 goes into 7 1 time. 7 goes into 14 2 times. Okay, sometimes we can cross cancel again, but in this case, 1 and 11 I can't do anymore. 1 and 2 I can't do anymore, so across the top I get 2 times across the bottom and I get 11. And my final answer is 2 11s, and that's as simple as it needs to be. Okay, let's try another one. Let's try 6 over 33 times 7 over 40. Okay, sometimes we have to reduce a couple of times. Well, in my head, I'm like, I don't remember what goes into both 6 and 40, but I think 2 does. They're both even. So I'm going to reduce this by 2, and this would be 20. Reduce this one by 2, and that gives me 3. Oh, but see how 3 and 33 have something in common? Well, just looking at that fraction, I know I can reduce that. So what goes into both 3 and 33? 3. So if I reduce this by a factor of 3, that gives me 1 on top. reduce this one by a factor of 3 gives me 11 on the bottom. Okay, that was just reducing that fraction there. Okay, 11 and 7, do they share anything in common? Nope. 1 and 20. I can check this way. 7 and 20 don't share anything in common. So multiply across the top, I get 7. Multiply across the bottom, I get 11 times 20. Now that's a big number, but that's a whole lot easier than doing 33 times 40 and then reducing after that. So 11 times 20 is, I'll just do it over here. So 11 times 20. 0 times 1 is 0. 0 times 1 is 0. Or we could have hung out the 0. 0 placeholder. 2 times 1 is 2. 2 times 1 is 2. Now I know some of you could have done that in your head, but for those of you that can't, I'm just showing you, you don't have to do it in your head. You can work it out, but that's smaller and as simple as we can make it. So I know my final answer is 7 over 220. Okay. One last one. Let's do 5/9 times 7/8. Okay, 5 times 8, or 5 and 8, do they share anything in common? Nope. Okay, 7 and 9, do they share anything in common? Nope. Because they don't share anything in common, I can be confident that when I multiply across the top and get 35, multiply across the bottom and get 56, or sorry, not 56, 72, then I know that this is as simple as I can get, and I don't need to find anything to reduce by. But it makes it easier if I do it here first instead of waiting till the end to reduce. All right, skip one line. We're going to be practicing mixed numbers to improper fractions. Okay, you'll need your colored pencils again for this. Okay, a mixed number is when we have whole units and a fraction with it. Improper fraction is when we have the numerator is larger than the denominator, meaning that there are some whole units found in there, but we decided to keep it in its fraction form. Okay, this is just a quick review of how to go from one to the other. So if you have the mixed number 4 and 2/3, let's draw a picture of what that would mean. That would mean 4 whole units. So let's draw 4 whole units. 1, 2, 3, 4. So 4 whole units. But then I need 2/3 of a whole unit. So draw another whole unit. But we're going to split that into 3 pieces. So if I'm going to shade this in, I would have 1, 2, 3, 4 whole units, and then 2/3. Okay, that would be in its mixed number form, but its improper fraction form, I want to know how many thirds are in the whole thing. So I'm going to split all my whole units into thirds. Okay, have I changed how much is shaded? Not at all. All I've done is chop these whole units into third-size pieces. So how many of those pieces do I have? 3, 6, 9, 12, 11, 12, 13, 14 pieces. So as an improper fraction, I have 14 pieces, and it still takes 3 to make the whole unit. Okay, now if I'm thinking backwards, let's try 13/5. Okay, this is going to be another one. So let's do 13/5. Okay, I need fifths, and I need 13 of those. So I'm going to draw a whole unit so that I can make fifths. And I'm going to split it into fifths. 1, 2, 3, 4, 5 pieces. Another one. 1, 2, 3, 4, 5 pieces. Now that would give me 10 so far. I'm going to just shade these in pink. Whatever color you have works. Now that's only 10/5. I need 13, so I'm going to draw another whole unit. and break it into fifths. 1, 2, 3, 4, 5, but I need 3 of those. Okay, there's my 13 pieces. But how many whole units did it take to make up these 13 fifths? Well, I have 3 whole units. So, I said 3 whole units. I'm sorry. I have 2 complete units and 3 pieces. So that would be 2 whole units and 3 fifths. So this and this are exactly the same in terms of number. However, this is just its improper fraction form, and this is its mixed number form. Now, we don't want to have to draw pictures every time we're doing this, so let's look at the trick. If I have whole numbers, I took my whole units and I split it into 3. So that gave me 4 groups of 3, so 3 times 4. So if I times my denominator here, that tells me how many pieces I'd have, but then I have to add the other pieces in with it. So 3 times 4 is 12, plus 2 is 14. Same thing here. 2 times 5 is 10, plus the 3 extra pieces, and that's where my 13 comes from. So if we try that with, let's say, 7 and 3/4. So 4 times 7 would be 28. So I'd have 28 pieces for my whole units. So 28/4 plus the 3/4 I already had. And that gives me a total of 31/4. Okay? Now I could try another one. What if I did 5 and 1/6? Okay, 6 times 5 would give me 30 pieces to make my 5 whole units. But then I need to add my 1/6 onto that. So 5 and 1/6 is the same as 31/6. Okay, what if I need to go backwards? What if I need to go from the improper form to my mixed number? Okay, well, opposite of multiplying and adding would be dividing and subtracting. So I'm going to take and divide and see how many whole units I can get out of my pieces. So let's say we have 18/7. So if I have 18/7, how many times will 7 go into 18? Okay, this is just a division problem. So 18 divided by 7. How many times will 7 go into 18? 2 whole times. So if I minus those 14 pieces, I'm left with 4 remaining. So remainder 4. So this would be 2 whole units and 4/7 left over. Okay, another example. What if I had 40/5? 15ths. Let's try that. So let's do 40/15. Okay, it's just a division problem, so let's put 40 inside the division box because it's my numerator or my dividend. I'm going to divide it by 15. Okay, 15 times 2 gives me 30. So minus 30. There's my 2 whole units. And I'm still left with 10 pieces left over. So remainder 10. So this is the same as 2 and 10/15. But we always want it in simplest form. 10 and 15 have a common factor. What is it? Okay, hopefully you thought 5. So if I divide by 5 to the top and bottom, my final reduced answer would be 2. 10 divided by 5 is 2. 15 divided by 5 is 3. So 2 and 2/3 would be my final most reduced answer for that one. Okay, make sure you write this in Unia's handwriting, and we'll see you tomorrow.